7 Unit 2 Solving. Lesson 9 Part 1 Solving Addition Inequalities. In the notes on page 35, important thing here, the addition property of equality and the subtraction property of equality, which means that you can add or subtract the same number on both sides of a true inequality and the inequality will remain true. For example, 6 is less than or equal to 8 is true. 6 plus 14, which is 20, is less than 8 plus 14, which is 22. Or I could subtract 6 minus 3, which is 3, is less than or equal to 8 minus 3, which is 5. Those are also true inequalities. So let's solve x minus 5 is less than negative 3. We followed the exact same steps we would if this were an equation. So we need to get rid of the negative 5, and you do that with the opposite, positive 5. We need to do it on both sides, the addition property of inequality. And x is less than, we just copy down the exact same sign, less than. Negative 3 plus 5 is 2. So our solution, x equals, or is less than 2. Now the most important number on this number line is going to be the number 2. I'm going to put some additional numbers on. You don't necessarily have to label every tick mark, but you do need to be consistent in your labeling so that it gets greater as it goes to the right and they're equally spaced tick marks. Okay, it does not include 2, but x is less than. Since x is less than, we are including numbers that are smaller, so our arrow needs to go towards the smaller numbers than 2. Solve the inequality, graph the solution. X minus 6 is greater than negative 7. We're going to get rid of the negative 6 by adding 6 to both sides. And y is greater than negative 1. Now the graph of that, we need to have negative 1 on our number line. And throwing a couple more numbers on here. Negative 1 is not included, so it's going to be an open boundary. Y is greater, so we need to draw the arrow towards the graders, and it would go that way. Okay, next example. B minus 3.8 is less than or equal to 1.7. We're going to get rid of negative 3.8 with a positive 3.8, and we need to do it on both sides. This gives us 0. B plus 0 is B, less than or equal to 1.7 plus 3.8 is 5.5. So B is less than or equal to 5.5. Now going to graph that, we need to have 5.5 on the number line. I'm just going to label, count by halves, but label every other one. 5.5 is halfway between 5 and 6. It is included. Now since B is less than or equal to, we're going to draw the arrow towards the smaller numbers. Okay, next example. Negative 1/2 is greater than z minus 1/4. We need to add 1/4 to both sides to get the z by itself. Negative 1/4 plus 1/4 is 0. Negative 1/2 plus 1/4, that's negative 2/4 plus 1/4 is negative 1/4. So we get negative 1/4 is greater than z. It's actually technically better to put the z first, but we'll take care of that when we graph anyway. So on graphing this one, since I am dealing with the number negative 1/4, I am going to count by fourths. But I'm going to only label every other one, so I don't have to write quite as much. Okay, so we start at negative 1/4, and this is an open boundary, so it will not be included. I'm going to do a circle, and x is less, or z is less than. Since z is less than, we're going to draw the arrow towards the left, the smaller numbers. Okay, examples in the notes. Example 260. Solve the inequality, graph the solution, and verify a solution. Okay, we're going to be verifying solutions. So x minus 3 is less than 10. We're going to get rid of the negative 3 with a positive 3 on both sides. This gives me x is less than 13, which now x is by itself. So my most important number on this number line is going to be the number 13. I'm going to throw some additional numbers on there. I'm counting by 1, but only labeling every other 1 by 2. Now 13, the boundary, is not included, but x includes smallers, so I go towards the smaller side on the number line to the left, and it does tell me to verify a solution. So I'm going to pick one of these solutions. Let's pick 10. 10 is a solution here. It's on the arrow. Is it true that 10 minus 3 is less than 10? Well, 10 minus 3 is 7. 7 less than 10. That solution does work. Now, we're not going to check every solution because we do not have enough time in the history of the universe to check an infinite number of solutions. So we will just check one solution. Okay, next example. Example 261. W plus negative 4/5 is greater than or equal to 1/2. I am going to add 4/5 to both sides. This gives me 0 here. Now 1/2 plus 4/5, I'm going to scratch paper this out. They are going to be tenths. 5/10 plus 8/10. By the way, I guess that could be done in decimal form. 5/10 plus 8/10. 0.5 plus 0.8. But anyway, 5/10 plus 8/10 is 13/10. So W is greater than or equal to 13/10. That would be our solution. Now graphing that solution, my most important number, 13/10, is a fraction. I could count by tenths, but that'd make the number line really zoomed in. I know 13/10, it's 1.3. It's going to be between 1 and 2. So maybe what I'll do here is count by a half. That looks pretty good. 1.3 is going to be between 1 and 1.5. About right here. And it is included, so I fill it in. W is greater than, so that means that the arrow goes towards greater numbers. And then I need to pick a solution and verify it. Let's do the solution 2 4/5. All right, 2 4/5 plus a negative 4/5 is going to be greater than a half. Well, 2 4/5 minus 4/5 is 2. Is 2 greater than a half? That is true. That solution is verified. Okay, let's move to the next example. Example 262. 5.3 plus v is greater than 9.2. We need to get rid of the 5.3 with a negative 5.3. And this gives us v is greater than, what would this be, 3.9? V is greater than 3.9 is our solution. Now 3.9 is between 3 and 4. I'm going to go ahead and count by halves, but only label every other one. 3.9 is going to be really close to 4. It is not included. I probably could have put it a little closer to 4. Okay. And it says v is greater than. Greater than would be bigger numbers, so we're going to draw the arrow towards larger numbers. Now we need to verify a solution. So let's pick 5. 5 is a good number. So 5.3 plus 5 should be greater than 9.2. And this is 10.3 greater than 9.2. That is true. Therefore, the solution is verified. Example 263. 81 is greater than s plus 111. We need to subtract 111 or add negative 111 to both sides to get rid of 111. That gets s by itself, and it is less than negative 30. Now, technically we should put the s first. But as we graph this, the most important number is negative 30. So I'm going to count by fives. but only label every other one. So negative 30, not included. So open circle. S is smaller. Since S is smaller, I need to go towards smaller numbers. And now I need to check a solution. I'm going to check the solution negative 111. It's way over here somewhere. You'll probably see why I chose that in a moment. Negative 111 plugged in for S plus 111. Oh, that's why I chose it. Negative 111 plus 111 is 0. That is easy to calculate. 81 bigger than 0, that's true. So checking the number negative 111 was a good choice. Okay.